Welcome, folks. All right, let's get started. Welcome to the 28th day of remote learning. Get this camera set up a little bit better here. There we go. All right. Today's joke: what is the worst joke in the world? This one. Apologies for that. Today, we are going to do some further review for more skills from this course that I want to make sure you've mastered before you move on to grade 10. I also had a question from Janelle. She asked me, Mr. Island, a few of us were wondering if you were willing to share how many stacks you make from streaming. I know it's sort of a personal question, so don't feel obligated to answer. Another question we've had is if you were willing to show us your gaming recording setup. PS, do you plan to improve your setup with accessories like an RGB mechanical keyboard, DX Racer, or neon LED lights around your room? If you do already have these, could you please show them? So those are great questions, Janelle. The first thing I did when I read those questions is I went to Urban Dictionary and found out what stacks means. And apparently it means $1,000. So how many stacks do I make from streaming? That is a very interesting question because it depends really how you define make from streaming. So my advertising revenue from streaming is a little low. I haven't been able to get a lot of viewers on my stream yet, so I'm not getting any advertising revenue from YouTube or from other sources. So in that sense, my revenue from streaming is quite low. On the bright side, though, I do get paid by my main Patreon supporter, the Waterloo Region District School Board, to do streaming, and because of their very kind support, I'm able to make a living off streaming, which has really been great. So I've been very happy over these last few months that I've been able to continue to make a living, even though I almost never leave my house, and I just do streaming as my main line of work. So big thanks to the Waterloo Region District School Board for their support. It's really appreciated. So the other question is, will I show you my gaming and recording setup? For sure. So we'll see. I'd have to click over to the live stream here. So this is the live stream in the live stream in the live stream in the live stream. There's my monitor. Over here, we have my desktop. Right here, we have my water bottle. And up there on top of the desktop, we have my old computer, which was the main computer I was using up until March of this year. And then shortly after March break started, it died. And now it's not working properly. It's not completely dead, so I'm trying to get files off of it. But that used to be my main computer, but then I had to replace it. So this is my setup. For my web camera, I'm actually using one that you've seen before. See, we can go right here. There it is. So this is the document camera from class. And we were able, after COVID-19, there was one day where they organized that teachers who needed to go into the school could go in one at a time with nobody else in there so that we wouldn't spread any COVID. We had to plan everything in advance, but we were able to go in and get anything that we needed in order to do online teaching and learning. And so I was able to go in and get the document camera, and that's what I've been using to make the videos. And that's been really helpful. I've also got this really sweet headset with microphone that I got just because it was a reasonable quality headset. And my old one had broken. This is a few years back, but now it's been really helpful. Oh, I maybe shouldn't have put that back. It's been really helpful for the streaming. So that's been really nice to have a decent quality microphone there. So that answers the second question. The third question was, do I plan to improve your setup with accessories like an RGB mechanical keyboard? Well, I have this really sweet mechanical keyboard here, and it actually is a mechanical keyboard. I don't really know a whole lot about gaming. I followed StarCraft and StarCraft 2 quite a bit when I was younger. And now I occasionally play some Hearthstone and a little bit of League of Legends. but I don't do very much gaming. So I wasn't aware of this whole mechanical keyboard thing until I had to buy this new computer and I had to get a keyboard. And because this computer came with a graphics card, an external graphics card not built into the CPU, it's considered a gaming computer. And I wanted the external graphics card because I've been doing some programming of 3D images, and I needed a graphics card in order for my programs to run fast enough. So when I bought a computer with an external graphics card, it came with a mechanical keyboard because it was considered a gaming computer. So I have this lovely multicolored computer keyboard that is mechanical. DX Racer was the next question. No, sorry, I have this wonderful chair that was left in the basement of the house that I bought recently, so I'm using it. So it'll have to do. Neon LED lights around the room? No, but when you asked that question, Janelle, that made me remember that when I saw the advertising for my computer, when I was looking at it on the website before I bought it, it looked like there were multicolored lights on it, but all that I've seen, and again, I'll maybe move this and show you here. All that I've seen on the computer is just this plain white light. So when you asked this question, I was like, oh, there's this white strip of light here, but I think it's supposed to do more than that. And I saw this button up here with a little light symbol next to it. And when I press that, then it starts to blink through different colors. And if I press it again, then I get kind of a fade in, fade out. And I can go through and get that in different colors, fading in and fading out. And then I was like, okay, I want it back to white now. Oh, there's white. Oh, but wait a minute, that's just doing fade out, fade in. Like I just want the solid white. And so I kept pressing it and I found it like fades through the colors. And then you can get this one and this one. And it just ended up being a lot of different possibilities and options here for what it could do. And it took me a really long time to finally get it to go back to just plain white. But there we are. So hopefully, if you were looking for some special LED stuff, you will consider that good enough for a streamer of my caliber. So hopefully, Janelle, that answers your questions. And for anyone else who wanted to know about my streaming setup, then you now have a little bit of information about that. And so when I told Janelle that I would answer this, she wrote back and said POG. So let's see some POGs in the chat to support Janelle's question before we jump into our mathematics. All right. Thank you, Alan. Nice to have your support. There we go. Thank you, Jordan. Thank you, Jackson. All right. Oh, am I rotating? Oh, this is good. Okay. All right. So let's dive into the mathematics. We have 4 skills up today. The first of which is distributive property. So a quick reminder before we do distributive property of one of the skills from a couple days ago, which is exponent rules, because we actually need them for the harder distributive property questions. And that is not on the screen. There we go. Okay. So when we're dealing with distributive property, we can have straightforward ones, which are like 2 times 3x minus 5. And distributive property just means that we distribute what's in front of the brackets over all the terms in the brackets. So we're going to get 2 times 3x. That's our first term. And our second term is minus 5. So we'll also get 2 times negative 5. And as always in mathematics, the sign goes with its term. So this is subtract 5. So that's minus 5 here. The minus sign has stayed with the 5. So the sign in front always goes with the term. And we're not quite done yet. We need to actually do these multiplications. 2 times 3x is 6x. 2 times negative 5 is negative 10. So the simplified version of 2 times 3x minus 5 is 6x minus 10. So that is our more straightforward distributive property. We can get some complicated ones here. So let me give you this one here. So this is multiple distributive properties in one. Minus 3 is multiplying everything in this bracket. It's not multiplying any of this. So what gets multiplied by negative 3 ends where this bracket ends. And as long as we remember that, it's not too bad to do this. So we're going to get negative 3 times 4x. And then negative 3 is also multiplying the negative 7. So we'll show that. And then here we are subtracting all of this, which is kind of like multiplying it by negative or negative 1 if you want. Some people like to just write a 1 in there and do negative 1 times 8x, which works out to the exact same answer. So we'll do negative of 8x and then negative or minus of negative 2. And now we can put those pieces together. Negative 3 times 4x is negative 12x. Negative 3 times negative 7 is plus 21. Negative of 8x is minus 8x. Negative of negative 2 is plus 2. And now we're done all the distributive property, but we still need to simplify as much as possible with our other simplifying skills. And in this case, that is to collect the like terms. So we have negative 12x and negative 8x. Negative 12 minus 8 is negative 20. So we have negative 20x, and 21 plus 2 is 23. So there is our distributive property, examples 1 and 2. There is one more difficult situation, not super hard, but we just need to be careful here. And that's going to be example 3. And before we look at it, I'm going to ask you to recall x to the power of 4 times x to the power of 5 equals x to the power of, and if you can tell me in chat what this exponent should be. What exponent do I get on the x when I multiply x to the power of 4 times x to the power of 5? Just type the exponent in chat. Thank you, Adam. Thank you, Owen. Indeed, we get x to the power of 9. So when we're multiplying two powers with the same base, we add the exponents. And that's going to be important here because we're going to be looking at questions like this. Where we have exponents on our x's. So just like the usual distributive property, we take what's in front and we multiply it by each of the terms separately. So 3x to the 5 times 7x plus 3x to the 5 from the front times 3x squared, our second term, plus 3x to the 5 from the front times 5, our third term. So each of these three terms, 1, 2, 3, got multiplied by 3x to the 5. 3 times 7 is 21. X to the 5 times x, well, that's like x to the 1. So just as we noticed here, we're going to be adding the exponents. 5 plus 1 is 6. 3x to the 5 times 3x squared. 3 times 3 is 9. X to the 5 times x squared is x to the 7. And for a final one, 3 times 5 is 15. X to the 5 doesn't have anything to multiply by, so it just stays x to the 5. So that is our review of distributive property. Let me know in the chat what questions you have, or if that's all making sense to you and you're feeling ready to move on, just give me a 1 in the chat. Thank you, Adam. Thank you, Owen. So what questions do the rest of you have? Thank you, Gabby. All right. So I'll keep an eye on chat. Please put your questions there. But at the same time, we're going to keep moving here. So the second skill is solving with distributive property. And on Khan Academy, where you're doing your practice, they call it equations with parentheses, which is also a reasonable way to describe it. Oh, distributivity, there we go. So this is if, for example, we have, and I'm going to try to get one here that gives us a fractional answer. So if we have -5 times 7x plus 4 equals 3 times -2x plus 8. So the first thing we want to do is to simplify the equation that we're working with as much as possible. So I'm going to do the distributive property on both sides. You don't want to mix the two sides together yet. We want to just work with what's there. So -5 times 7x minus 5 times 4. So that's that distributive property. There's the equal sign. And then over here, 3 times -2x plus 3 times 8. So we get -35x minus 20 equals -6x plus 24. And now we're down to or closer to our normal equation. This one does have variable on both sides, but we've definitely done those before. In fact, I think our last lesson we looked at this type of equation and reviewed it. So we're going to move all the x's to one side, all the non-x terms to the other. So I'll get -35x. I'm going to add x on, or add 6x on both sides. And I have -20, and I'm also going to add 20 on both sides. So over here, I get -6x plus 24 plus 6x, and then plus 20. So the 6x got added to both sides, the 20 got added to both sides. And what that's going to do, -20 plus 20, that adds up to 0. -35x plus 6x is going to be -29x. -6x plus 6x is 0, so those cancel each other out. And then 24 plus 20 is 44. And now we're down to the simplest type of equation. We can just divide both sides by -29, and we will end up with x equals 44 over -29. What questions do you have about solving with distributivity? Let me know in the chat, or if you are feeling like you are ready to keep moving, give me a 1 in the chat, please. Thank you, Adam. Thank you, Owen. Thank you, Gabby. right. So again, if you have questions, please put them up in there. I'm noticing we're getting less people giving ones today than usual. So if you do have questions, I really encourage you to ask them. This is a chance to get a live explanation about things. And it seems like there's quite a few people who have questions or at least some reservations about these skills. So, please let me know in the chat what your questions are. And that way I can answer them for you now. Thank you, Jordan. Okay. So I'll keep an eye on chat for those questions. The next one up is manipulating formulas. So let's move this up. And we often have called this in the past rearranging formulas when we did the lesson. Khan Academy calls it manipulating formulas. It is the same thing. Okay. So this is when we have a formula like perimeter of a rectangle equals 2 times the width plus 2 times the length. And we want to know if we had, say, the perimeter and the length, then how would we get the formula for the width? Oh, and I'm seeing a question in chat. Thank you, Jackson. That's awesome. Okay, yeah. So Jackson, you're asking about the solving one, or are you asking about the distributive property itself? Second one. Okay, cool. Thank you. Yeah, so here we have an equation. As with all of our equations, we're trying to find what value of x is going to make this side equal to this side. And we have our rules, our regular rules for solving equations that you know, which is we want to do opposite operations and we want to do the same thing to both sides. The problem here is that we have stuff in brackets. And so if I just start undoing the operations that are here with opposite operations, and let's say like I divide this by -5, because I'm like, oh, it's -5 times some stuff, so I'll divide by -5 and then the -5 will go away. It's true that that will make the -5 go away, but then what I'll end up with is 7x plus 4 equals 3 divided by -5 times -2x plus 8. Now, it's possible to go through and solve this, but we're going to get fraction math all the way through. And fraction math isn't bad, like we know how to do it, but it definitely slows things down. So instead, what we're going to do is we're going to apply the distributive property. So, oops, here we go. So we have -5 times all of 7x plus 4. So just like what we did in the previous skill where we were simplifying, we're going to treat each side of the equation like a distributive property simplification. So I'm going to multiply -5 by 7x. I'm going to multiply -5 by 4. So that's what's shown here, -5 times 7x, -5 times 4. And then on the other side of the equation, we're again going to say, okay, this is a distributive property. I can simplify it and get an equivalent expression. So I'm going to multiply the 3 by both of the terms. 3 times -2x, there we go. 3 times 8. And then when I simplify that, 3 times -2 is -6. Keep the x. 3 times 8 is 24. And so I get an expression, -6x plus 24, that has the same value as the original expression. And that should happen anytime we simplify, we should get an equivalent expression. So that means if I sub in some value for x here and calculate this, and I sub in the same value for x here and calculate this, I should get the same answer. So let's pick, I don't know, 5. -2 times 5 is -10. -10 plus 8 is -2. -2 times 3 is -6. So here, if x equals 5, then the expression equals -6. Down here in the simplified form, if x equals 5, -6 times 5 is -30. -30 plus 24 is -6. So if x equals 5, then the whole expression has a value of -6 here as well. And that's the key, is that when we simplify, we don't change the value. You will still get the same answers no matter what x you plug in, but we have it in a simpler way that's easier to use. Okay. So now once we get it here, where there's no more brackets, now we can just start using our regular equation solving. So I have a -20 here. I did it all at once on this line, which is maybe a bit confusing. But because I have a -20, I'm going to add 20 to both sides. So there's my +20, there's my +20. And so 24 plus 20, that's how I got the 44. I also wanted to go and get this -6x and make it go away from this side and end up on the other side. So I added 6x to both sides, plus 6x plus 6x. So the -6x plus 6x, that makes 0. So all that was left over here was the 44 from 24 plus 20. On this side, I had -35x plus 6x minus 35 plus 6 is -29. So we have -29x equals 44. And then I just finished it off by dividing both sides by -29. So let me know if that makes sense or what other questions you have about it. Is there a specific detail there that's not making sense? Is there something more you'd like to know? Okay, great. Thank you, Jackson. All right. So let's look at rearranging formulas. So once again, we're going to be reusing the skill of manipulating an equation that we do when we solve it. But now, because we have more than one variable, we can't solve and get a number, but we can use the solving steps to rearrange. So if I have this formula and I want to know what is the formula for the width of a rectangle if you know the perimeter and the length. So I want to rearrange to get a formula for W. So the first thing I'm going to do, I want to get this W all by itself. So I want this 2L gone from this side. So I'm going to subtract 2L, right? We have plus 2L, opposite is subtract 2L. So that's going to make the plus 2L go away. 2L minus 2L is 0. So we end up with 2W. And over here we have P minus 2L. So now I've almost got the W by itself, but I need to divide by 2. Divide by 2. And then here I will get P divided by 2 minus 2L divided by 2 is just L. 2 divided by 2 is 1 times W is W. So now I have my formula for the width if I know the perimeter and the length. And I can rewrite it with the W on the left side, P divided by 2 minus L. So this says, for example, if P equals 20 centimeters and L equals 6 centimeters, then W is going to equal to 20 divided by 2 minus 6. 20 divided by 2 is 10. 10 minus 6 is 4. So that tells me if my perimeter is 20 centimeters and my length is 6 centimeters for a rectangle, I'm going to have a width of 4 centimeters. And we can see that that checks out, right? If my width is 4 and my length is 6, 2 times 4 is 8, plus 2 times 6 is 12. 8 plus 12 is indeed 20. So that does work out as the correct width to go with a length of 6 centimeters and get a perimeter of 20 centimeters. Okay. So if you have questions, put them up in the chat. I'm going to do a second example with a little bit more complexity to it, just slightly trickier operations, really. So another example here, c squared equals a squared plus b squared. So this is our familiar Pythagorean theorem. We usually use this to find the hypotenuse. We know the other two sides, we square them both, we add them together, we get the hypotenuse. If we want to rearrange for b, so I want to know what's my formula if I know the hypotenuse and I know another side, what is my formula for b? Well, the first thing I'm going to do is get the b squared part by itself. So I want this a squared gone. So I'm going to subtract a squared from both sides. C squared minus a squared stays. And then here I have a squared minus itself, which is 0. B squared is all that's left. And we often just use the formula in this situation, or in this format, or rearrangement, but it's actually asking us to rearrange for b, not for b squared. So I have to think, how do I undo a squaring? What's the opposite of a squaring? And be careful, because some people think, oh, it's dividing by 2, but that's not true, because squaring is not the same as multiplying by 2, right? 3 times 2 is 6. 3 to the power of 2 is 9. So they're not the same thing. So the actual opposite operation is square rooting. And so I'm going to square root both sides. The square root of a square, that cancels. And I end up with just square root of c squared minus a squared as my formula for b. And we can rewrite that to put the b on the left side. And there we go. And again, we can prove to ourselves that this has worked out correctly. So we can try out an example. If a equals 3, b equals 4, c squared equals 3 squared plus 4 squared. C squared, 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25. And then c is going to be the square root of 25, which is 5. So that's the original one. Does this formula get us the right answer now? So if we have b equals square root of c squared minus a squared, well, c is 5, so that's going to be 5 squared, minus a is 3, so that's going to be 3 squared. 5 squared is 25. 3 squared is 9. 25 minus 9 is 16. And then when we square root that, we end up with 4. So you can see here that we do indeed, if we start with 5 for our C and 3 for our A, get the correct answer of 4. All right, what questions do you have about rearranging formulas? Feel free to give me a 1 in the chat if that's making sense and you're ready to move on to the next skill. Thank you, Jordan. All right, seems like this one we have a lot of questions as well. So please, I encourage you, send me your questions. Let me know what you're wondering about this. We're going to use this rearranging skill in various ways throughout the next few years. So this idea of taking an equation, and even if there's lots of variables in it, being able to do opposite operations on both sides and get it into different forms is something that we'll make use of very frequently. So I'll keep an eye on the chat. If you have questions, you can put them up there. I want to talk about our last skill for today. And this one is the opposite skill of one that we talked about last time. So last time we had an equation and we talked about how to draw the graph for that equation. This time we have a graph and we want to draw the equation, or we want to write the equation. So I'm going to try and do this real careful here so I get it perfectly right. We're close to it. All right. So there we go. Oh, that is not focused. All right. So given the graph of a line, how do we get the equation? And so a quick reminder, we usually like to write the equation in a y equals mx plus b pattern, where m is the slope of the equation and b is the y-intercept. So let me just label our axes a bit here. 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, and that's all we need. Okay, so I would recommend starting with the y-intercept. You can start with the slope if you want, but the y-intercept's usually pretty easy. So you just look on the y-axis, where does the line cross? And so this one I can see, oh, it's crossing at 1. So I know b equals 1. My y-intercept is 1. There's that crossing point. Then you want to find two spots where your line crosses a grid crossing. In other words, there's a horizontal grid line and a vertical grid line coming together exactly at a point on your line. So this would work. This one doesn't work. It's got a vertical line crossing, but the horizontal line is up here. It's not where my red line is. This one also doesn't work. It's got a horizontal line through it right there, but there's no vertical line crossing here. So we want to look for the spots where both vertical and horizontal are at the same part of my line. And that's going to give us a whole number for the coordinate, right? So the coordinate of this point are 3, 3. We get whole numbers or integers if they're negative as our coordinates. So that's really helpful. We need to find two of those. So I've got one here. It's 0 and 1. And I've got a second one here, 3 and 3. And by the way, it doesn't matter which two you pick. You can pick any 2 points on the line, and your calculation will always give you the same answer once you've simplified it into lowest terms. So we're just going to use our slope from 2 points formula. So I'm going to call this my initial point and this my final point. So we're going to go y final minus y initial divided by x final minus x initial. And so x and y, x and y. So y from the final point is 3. Y from the initial point is 1. X from the final point is 3. X from the initial point is 0. And 3 minus 1 is 2. 3 minus 0 is 3. So I have a slope of 2/3. And that tells me to get from one point on the line to the next, I can move up by 2 and over by 3. And that's where we end up. So now I'm ready to write my equation. Therefore, the equation is y equals m, which we found is 2/3, x plus b, which we found is 1. All right. So that is how we go about getting the equation from the graph. Let me know in the comments what question you have. And if you're feeling comfortable with that, you can give me a 1 in the chat. Or sorry, not let me know in the comments. Let me know in the chat what questions you have. And if you're feeling comfortable with it, you can give me a 1. Thank you, Jordan. Thank you, Gabby. Thank you, Jackson. Thank you, Adam. All right. So, Jackson, for that 5% there, feel free to send me a message. Or if you have a question now, I'll stick around for a little while. But if you want to try it out yourself a few times and see how it goes, then you're welcome to send me an email with specific questions, and I'll be happy to answer. Or just if you want me to go over it with you again, I'm happy to do that. All right, folks. So those are the 4 skills for today. On Monday, we'll do 4 more. I've had a lot of questions about marks, and I should be pretty close to determining those. Sometime next week, I expect that I will get out into the classroom a set of marks for you so that you can see where your mark is at. And again, I just want to emphasize the thing that I've been saying ever since remote learning started, which is that we don't have enough information for a precise and accurate mark. So teachers really we had a strong opinion that this semester should be just you get the credit and there's no mark attached to it. Unfortunately, the Ministry of Education said, no, you have to assign a mark. So I apologize. I know these marks are not going to be accurate, but given that we've had so little opportunity to do assessment, there's not much I can do about that. So I am going to try and err on the side of benefiting you rather than err on the side of lowering your mark. And so I'll try and get those out to you next week, and then we can talk about them. If you think that the mark that I've assigned doesn't really reflect your knowledge, let me know that. We'll talk about it. We may arrange for me to have a chat with you and so that you have a chance to show some of your knowledge, and then I can make adjustments as required. So that is it for today. I will see you all again on Monday. Take good care.